Welcome back to Algebra 1 with Miss Betsy. Today we are continuing our discussion of working with rational expressions by learning how to multiply those. Before we get started though, I've got a question for you. I wonder if you can tell me how you would define a will. Well, a will is just a dead giveaway. If you are in my text that I am using, it's Algebra 1 for Christian Schools. This video uses the second edition. I'm in section 12, chapter 12, section 2. It's called Multiplying Rational Expressions, and I am on page 485. And we're going to begin with just a brief reminder of what do you do when you multiply rationals. Remember, multiplying rationals is just like multiplying two fractions together. They're rational numbers, rational expressions, and if you had 2/3 times 3/7, our basic rule says that we're going to multiply the numerators and we're going to divide that by the product of the denominators. So we multiply numerators together and we divide that by the product of the denominators. And you can do your multiplication first, which would say that you had 6 divided by 21, but then you'd have to reduce it. So you have learned that when you're multiplying rational numbers together, then it makes a whole lot of sense to cancel common factors before you multiply, because then your simplification is much easier to do. 2/3 times 3/7 is 2/7. You don't have to go at 6 times 21 and then go backwards and reduce. So then in our lesson today, we're going to see how that works with rational expressions. But we're going to do just first a couple of just reviews. 5/9 times 27/40. This is example 1 on your text, and that is found on page 485. Now we could go ahead and say 5 times 27 would be what? 135 divided by 360. Well, then you have to factor those larger numbers. Why don't we just recognize that we have a factor of 5 in common? 5 times 8 is 40. So we factored out a 5. We have a factor of 9 in common here. 9 divided by 9 is 1. 27 divided by 9 is 3. What do we have left? We have 3/8. Okay. Obviously, I'm not spending time showing you how we factor this because this is old material that you already know how to do. But this is a review of the procedure of how you cancel common factors when you're multiplying rational numbers together. We're going to carry that same concept over into multiplying rational expressions. Let's go ahead and look at example 2. And this is on page 486. Let's see if I can see this with my glasses. 3a divided by 2ab. 3a divided by 2ab times 12a divided by 18bc. And now I'm having trouble with these bifocals, so that's my concession to getting a little bit older here. So let me check and make sure that they're right. 3a divided by 2ab times 12a divided by 18bc. What I want to do now is find common factors here that I can cancel. Well, what do I have here in this term? I've got a factor of a and a factor of a that I can cancel here. Nothing in common as far as the variables go, but I have a factor of 6 that I can factor. 12 divided by 6 is 2. 18 divided by 6 is 3. Well, am I finished reducing my fraction yet? Well, no, because look, now I have a factor of 3 in common that I can reduce. I also have another factor of 2. So by canceling common factors early, I see that I've eliminated everything in the numerator except a. I'm going to divide by the product of the denominators. What do I have left? I have b times c. B squared times c. So this is the answer to the multiplication of these two rational expressions. It's a divided by b squared c. And we made our simplification easier by canceling factors before we multiplied. Okay? Let's go ahead and see what in the world I did with my eraser. And try one more example here. And these just get messy when you're doing your cancellation and drawing your marks through it, so you've got to be careful that you are that you're doing your work neatly enough that you don't get lost in all of the cancellation. So what does example 3 say? It says 5x squared y divided by 2x cubed z times 24x y squared z to the 5th 10 times x times y. Got quite a lot going on here. Let me verify. 5x squared y, 2x cubed yz, 24xy squared z to the 5th, 10xy. Let's look here and see what common factors we have to cancel. Let's start with the coefficients first. 5 and 10, we have a factor of 5 that cancels, leaving a factor of 10 because 10 divided by 5 is 2. Now what do we have? Well, we have a factor of 2 that will cancel here, leaving a 12 in the numerator, correct? 24 divided by 2 is 12. We have a 2 and a 12 again, leaving a factor of 1. 2 goes into 12 6 times. Now I'm looking and I'm saying, okay, the only coefficients I have remaining are this 6, so there's nothing else that I can cancel. Now, what about my x's? Well, x divided by x, those cancel. X squared, x cubed, the x's in the numerator cancel, leaving us x to the first in the denominator. What about y? Y divided by y. Okay, I have a z in the denominator. I have a z to the 5th here. Z to the 5th divided by z. We have one factor of z that cancels, leaving us, see how messy this is getting? Z to the 4th. Okay? Now what do we have? Crossed out, crossed out, crossed out. Cross, 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 cross. We have a factor of x left. What do I have here? 6 y squared z to the 4th, but I've got a y left. So this y cancels, leaving me a factor of y in the numerator. Now let's go back and look and see what we have. Okay, nothing here except the 1. Nothing in this denominator except the x. see we have a 6y z to the fourth and nothing in the denominator of this rational expression. So let's see if we are correct. 6y z to the fourth. I have that all over a denominator of x. And if you check your answer on page 466, that's exactly what we've ended up with. You might want to write a couple of steps in here instead of just cancel. You might want to do partial cancellation because it can get messy when you're trying to reduce so much stuff going on at one time. But we cancel common factors to come up with our reduced rational expression here. Now let's jump right into where we have, instead of just monomials, where we have polynomials that are more than one term, and see what we're going to do before we multiply. This first example that they give to us here is example 4. This is found on page 486. We have x plus y divided by 9 times 18 divided by x squared minus y squared. You think, okay, I at least see that I can divide, cancel factors of 9 from 9 and 18. But let's go ahead and see, is there anything else we can factor? X squared minus y squared. You should all recognize this as the difference of two squares. So this becomes x plus y divided by 9 times 18 divided by x plus y times the quantity x minus y. Be careful to enclose your factors in parentheses so that you make sure that you're canceling only common factors, not terms, only factors. A 9 cancels, leaving us a factor of 2 in the denominator. Our x plus y factor cancels, leaving us the factor of x minus y in the denominator. We have reduced this rational expression. We've multiplied it, canceled common factors to give us 2 over x minus y as the final form of the multiplication of these two rational expressions. Okay? Pretty straightforward. Looks weird, but when you remember that we're just putting everything together, you're factoring a perfect square, then it's not really so bad, is it? It's just different than what you're looking for, different than what you're accustomed to working with. Let's go ahead and look at example 5 on our next page. And this says simplify x cubed minus x squared minus 72x times 3 over x squared minus x squared plus x minus 56. And you think, oh my word, what in the world am I supposed to do there? I don't see a single thing I can do. Well, remember that you can make anything look like a rational expression by dividing it by 1. And we must be supposed to factor something here. Say x cubed x squared x. Do you see that we have a common monomial factor of x? And then we have x times x squared minus x minus 72 divided by 1 times 3 over, let me just go ahead and not factor that denominator yet. Now, what do we have? we have two trinomials that we're going to be able to factor. And you'll be glad to know here that when we're canceling common factors, when we're working with multiplying rational expressions, you're not going to be getting into using that quadratic formula. You're going to have to be able to factor our trinomials by inspection. We need a product of negative 72, a sum of -1. That's easy enough because 9 times 8 is 72. We need to have a sum of -1, so it's x minus 9, x plus 8, all of that over 1, plus 3 times, okay, what factors equal 56? 7 times 8 are 56. One factor's negative, one factor's positive. It's going to be x plus 8, x minus 7, because our center term has a positive coefficient. And also a little cheat hint here is that we know that in all likelihood we're going to have something that can cancel. So this is the factor right here that's going to cancel. Factor of x plus 8 we find in both the numerator and the denominator. So what do we have left? If we want to leave this in factored form, we have 3 times x minus 9, all of this, divided by x minus 7. Let's go ahead and check our problem. And you see that this is exactly the simplified form after we have multiplied two rational expressions together. You can tell that it's going to take you a bit of workspace to come up with these answers. It's straightforward if you've been diligent to keep up with learning how to factor and recognize special products. It's not going to just eat your lunch. It might take you a while to do these problems, but it's very methodical. Break trinomial expressions or into factored form, look for common factors and cancel them. And then trust your answers that just look really different because, doing this multiplication together to get 3x times quantity x minus 9 over x minus 7 is a lot different than saying 2/3 times 3/7. And we're going to cancel the factors of 3 and end up with 2/7. We're used to looking to something that looks like 2/7 and being a simplified form. This looks different to us, but it's the same principles. These are the same procedures that we're using. Go ahead and take your time working on this, and I'll see you next lesson.